These days, we speak to each other through the internet, we get our news through the internet, we shop on the internet, we bank on the internet, we watch our videos on the internet. In fact, you and I are speaking through the internet right now. Internet has become such an integral part of our lives, many of us simply can't live without it. Our lives stop if the internet is down for any significant amount of time. But have you ever wondered how this magical thing actually works? I was actually surprised that the 10 different people I spoke to did not know how internet actually works, at least not the full story. That is why I decided to do this video and talk about this extremely simple yet overly complex thing that is controlling our lives. I will talk about 4 different pieces to this internet puzzle, and I promise I will try to keep it as simple and as straightforward as possible to follow. Let's go. The first piece of this puzzle is very simple. Let's call it convert everything to the language the internet speaks. Everything that needs to be sent on the internet gets converted into a whole bunch of zeros and ones, which is the only language the internet speaks. They get sent to whoever they need to be sent to and wherever they are located. On the recipient's end, these zeros and ones get converted back to whatever the sender wants to convey. For example, this video in the form of various zeros and ones is being transmitted to you from the YouTube server as we speak, and these zeros and ones are getting converted back to this video on whatever device you are watching it in. Easy peasy lemon squeezy, very simple. But obviously, it cannot be converted into random sets of zeros and ones. There should be some method to this madness. So they have to be converted into mutually agreed sequence between the sender and the recipient so they can be properly encrypted or packaged on the sender side and decrypted or unpacked on the recipient side. That is where the binary code comes into picture. Everything that gets transferred over the internet, it gets converted into a specific standard set of zeros and ones. Characters, numbers, images broken into all the pixels they are made up of, voice, and videos, which are nothing but a collection of images bundled together. They all speak a universal language of zeros and ones. For example, this is how a lowercase a gets converted or gets transferred over the internet. 11000001. But the good news is you don't need to understand this language computers speak. I think it's good enough as long as you understand that similar to how the English language has 26 characters or 26 alphabets, digital language only has 2 numbers and no alphabet at all, and that's 0 and 1. That's all computers speak. Now comes the second piece of the puzzle. Transmit the zeros and ones. So everything is converted into zeros and ones on the sender side, but then what? How does it get transferred? I will give you an example. Take a torchlight and flash the light once, twice, and don't flash it 4 times and then flash again. That's 11000001, and that represents a lowercase a. So every time you flash the light, that is representing a 1, and when you are not flashing the light, that's representing a 0. This is the lowercase a we looked at earlier. That's a very easy way to understand how the data gets transferred on the internet. But light is only one way to transfer internet data, and this is the technique used in fiber optic cables, the most popular way the data is transferred on the internet. Electrical signals could also be used to transfer zeros and ones, and that is what the copper wires use, which is what Ethernet cables and telephone lines use. So it's either light or electric signals. The other way is transferring wirelessly through Wi-Fi that converts the zeros and ones into radio signals that are translated back into electrical signals at the other end, whether it's the router, a laptop, or a smartphone. And this is similar to how a mobile phone sends the data as well. And these are the most popular ways to transfer data on the internet. It sounds simple, but it is not that simple in reality. For example, this video you are watching today contains approximately 6.4 billion zeros and ones. That's a billion with a B. That would be a lot of electrical signals in the case of copper wires and light flashes in the case of fiber optic cables. But this is just one video. Imagine how many people watch this video alone and how many people are watching how many videos in the world right now. Add that to all the other activity that is currently going on the internet right now as we speak. Is it practically possible for everyone else to wait, halting the entire internet traffic for you until all these 6.4 billion signals are sent to you and they are decoded on your end? No, because you're not the only one on the internet roads. So how do you manage all this heavy traffic? Again, that's a lot of zeros and ones. That brings us to the third piece of this puzzle. Send the data in small packets. Your 6.4 billion zeros and ones are divided up into multiple packets and sent, and the internet roads will be full of these packets that belong to everyone around the world. Once these packets reach the destination, they are sorted and arranged in the right order, just like a sorting facility. So now you have all these packages or packets ready, but how do these packets know where to go? That brings us to the last piece of this puzzle. Use the destination address to send these packets. Similar to how we send physical packets, that is by writing the destination address, these digital packets on the internet will have the destination address as well, and we call it the IP address, Internet Protocol Address. To summarize, everything you do on the internet gets converted into a whole bunch of commonly agreed upon zeros and ones. They will be divided up into packets, sent through light signals, electrical signals, or radio waves to the destination by its address, and the packets are sorted back to form the original content you wanted to send, whether it's an email, a WhatsApp message, a Facebook post, a YouTube video, or a TikTok short. This is obviously the simplistic view of the internet. Hope you enjoyed it. Stay tuned for more videos on technology and leadership. As always, my goal here is to simplify complex topics, bring unique perspectives, and bust some tech and leadership related myths. See you all in the next video. Till then, take care and be safe.